So welcome grade 8 students. Please go to www.cathomeschool.com. Okay, then click for the curriculum. Then enter the password. Okay, then click for mathematics because that will be our lesson for today, mathematics. All about linear equations. So first, what what is a linear equation? Are you ready? Okay. So a linear equation is an equality between two algebraic expressions involving an unknown value called the variable. In a linear equation, the exponent of the variable is always equal to 1. The two sides of an equation are called right-hand side and left-hand side. They are written on either side of equal sign. So, for example, 4x plus 3 equals to 5. So, the left-hand side is 4x plus 3 and the right-hand side is 5. Same as number 2. The left hand side is 2x plus 5y and the right hand side is 0. And number 3, the left hand side is 2x plus 3y and the right hand side is 6. A linear equation in two variables can be written in the form of ax, by, and c, where a, b, c are real numbers and a, b are not equal to 0. So, example, 2x plus 3y equals to 9. So, a is 2x, b is 3y, 9 is c. Another example, x plus y over 4 minus 4 equals to 0. So the a is x, which is equivalent to 1, and the b is y over 4, which is 1 over 4, and the c is negative 4. Another 5 equals to 2x, so the a is 2x, and the b is 0, c is 5. Another one is a is 0, b is y, which is 1, and c is negative 2x. Okay, next, 2 plus x over 3 equals to 0. 2 is c, b is 0, a is 1/3. Okay. A linear equation is an algebraic equation in which each term is either a constant or the product of a constant and a single variable. Linear equations can have one or more variables. Linear equations occur with great regularity in applied mathematics, while they arise quite naturally when modeling many phenomena. They are particularly useful since many nonlinear equations may be reduced to linear equations by assuming that quantities of interest vary to only a small extent from some background state. So, every linear equation has a unique solution as there is a single variable in the equation to be solved, but in linear equation involving two variables in the equations, a solution means a pair of values, one for x and one for y, which satisfy the given equation. So examples, x is equal to 2x plus 3y. So if x is equal to 3, 2x plus 3y is equal to 2x 3 plus 3xy equals to 12. because and 6 plus 3y equals to 12. So y equals to 2, and then therefore the solution is 3 and 2. Next, if x is equal to 2, 2x plus 3y equals to 2x2 plus 3xy. So 4 plus 3y is equal to 12. So y is equal to 8 over 3. Therefore, a solution is 2 equals to 8 over 3. Similarly, many other solutions can be taken out from this single equation. That is, a linear equation in two variables has infinitely many solutions. So a graph of linear equation in variables. So graph of linear equation is representation of the linear equation GU. Observation on graph. Every point whose coordinates satisfy the equation lies on the line AB. Every point on the line AB gives a solution of the equation. Any point which does not lie on the line AB is a solution of the equation. So here is the graph. You can see the y and the x-axis. Okay. Next is equations of line parallel to x-axis. The graph of y equals to a is a straight line parallel to the x-axis. So examples, 2y minus 7 equals to 1. So 2y minus 7 plus 7 equals to 1 plus 7. 2y equals to 8. 2y over 2 equals to 8 over 2 equals to y over 4. So y is 4. So that's why we circle it to y over 4. So the graph of x equals to a is a straight line parallel to the y-axis. So as you can see, we graph it in the number 5. Okay. So we have here examples and solutions. Number 1, give the values of a, b, and c. So negative 2x plus 3y equals to 9. So a is equal to 2, b equals to 3, c equals to 9. Negative 9. 5x minus 3y equals to negative 4. So a is equals to 5, b equals to negative 3, and c is equals to 4. Next, 3x plus 2 equals to 0. So a equals to 3, then b equals to 0, and c equals to 2. Lastly, y minus 5 equals to 4. So the a is 0, b is 1, c is negative 5. So another one, solutions for each. So here is it. Okay. Here is the graph of the equation of 2 plus 2y equals to 6x. As you can see, the y-axis and the x-axis, if x is equal to 2 and y equals to 5, so they graph it according to the solutions of x and y-axis. Okay, an equation of the form ax plus by equals to c equals to 0, where a, b, and c are real numbers such that a and b are not both 0, is called a linear equation in two variables. A linear equation in two variables has infinitely many solutions. The graph of every linear equation in two variables is a straight line. So x equals to 0 is the equation of the y-axis, and y equals to 0 is the equation of the x-axis. So graph of x equals to a is a straight line parallel to the y equals to x y-axis. The graph of y equals to a is a straight line parallel to the x minus axis. An equation of the type y equals to mx represents the line passing through the origin. Every point on the graph of a linear equation in two variables is a solution of the linear equation. Moreover, every solution of the linear equation is a point on the graph of the linear equation. So that is, but oh my god, what happened? Don't worry, because I have a video that will further explain the topic linear equation. Okay. This is for basic examples.
Y is equal to 3x, x is equal to 3y. Consider the system of equations above. How many solutions does this system have? Well, when I think about solutions to systems, I always imagine each of the equations in our system is kind of describing a line. And if the two lines intersect, you're going to have one solution. And if they don't intersect, you're going to have no solutions. And if they end up being the same line, so if they end up being the same line, you have an infinite number of solutions. So let's see, and so we can immediately rule out, because these are linear equations, two solutions. The only way you're going to have two solutions is if one of these lines, at least one of them curves, one of them did something like this, then you could have two solutions right there and right there. But these are both linear equations, so we can rule out having two solutions. So, but let's just think about these up here. Well, what I like to do is let's solve them both explicitly for y. That's at least how I like to visualize lines. This first one up here is already written explicitly in terms of y. The second one over here, let's divide both sides by 3, and we get y is equal to x over 3. So this first one is y is equal to 3x. The second one is y is equal to x over 3, or we could say 1/3 x. And so these lines, they don't have the same slope. So they're not going to be parallel, and they're not going to be the same line. So these are going to intersect. These are going to have one solution, exactly one solution. If you wanted to visualize this on the coordinate axes, I'll do it really fast. If that's our y-axis, this is our x-axis, x, y. This first line right over here, this is going to have a slope of 3, so it's going to be a pretty steep line. It's going to look something like this. And then the second line right over here is going to have a slope of 1/3, so it's going to look something like this. These two clearly intersect. And actually, now that I look at it, one way to realize that you're going to have at least one solution, and then you'll see it, and you even see it where they're intersecting right over here, the solution is when x and y both are equal to 0. But since you want to rule out that, hey, maybe it has an infinitely many solutions, look, just think about what these lines represent. This first one, very steep line right over here. The second one, a much less steep line, but they're different lines, so they're not the same line, and they don't have the same slope, so they're not going to be parallel. So they're going to intersect in exactly one point.
Okay, I have another video about solving system of linear equation. In this is harder examples.
Consider the system of linear equations above. Which of the following choices of A will result in a system of equations with no solutions? No solutions. So a system has no solutions is if both lines, and these are both linear equations, they actually tell us these are linear equations, is if you have two lines that are parallel, then you have no solutions. They're never going to intersect. There's no XY pair that satisfies both of them. So if they are parallel, then you're going to have no solutions. So what makes two lines parallel? Well, if they have the same slope, but they have different y-intercepts, you're going to be parallel. So essentially we need to pick the A here that makes the second line parallel to the first. And to do that, I'm going to actually write both of them in kind of the slope-intercept form, where y is equal to the slope times x plus the intercept. So let's do that. Let's do that for both of these. So first I'll do this one up here. So you have 9x minus 14y is equal to negative 3. See, if I subtract 9x from both sides, I would get negative 14y is equal to negative 9x minus 3. See, if I divide both sides by negative 14, I'm going to get y is equal to negative 9 divided by negative 14 is positive 9 over 14x, and then plus 3 over 14. So that's this line written in slope-intercept form. Now let me write the second line in slope-intercept form. So I have 2x minus ay is equal to negative 6. And let's see, if I subtract 2 from both sides, I get negative ay is equal to negative 2x. I'm subtracting 2x from both sides, so I get minus 2x minus 6. And then I can divide both sides by negative a, and I get y is equal to negative 2 divided by negative a is positive 2 over ax, and then plus 6 over 6 over a. All right. So we need to set up a situation. Where 2 over a is equal to 9 over 14. These two things have to have the same slope. And then when we're able to figure out that a, we have to verify that they have different y-intercepts, because if they have the same slope and the same y-intercept, instead of having no solutions, they would have an infinite number of solutions, because then it would be the same line. But let's solve for a. So we know that 9 over 14, needs to be equal to 2 over a. Or another way of thinking about this, we could take there's a bunch of, sometimes people say cross multiplying and all of that. I like to just do logical algebraic operations. But we could take the reciprocal of both sides. So we could have, and actually let me swap both sides. So we could say a over 2 is equal to 14 over 9. And then multiply both sides by 2. And you're going to get a is equal to 28 over 9. A is going to be this right over here. This is 28 over 9. So if I'm under time pressure, I already see a choice that's looking pretty good. But if we really want to care that, if a is 28 over 9, these two things are going to have the same slope. But let's make sure they don't have the same y-intercept. And I wouldn't do this if I was under time pressure, but just to feel good about it. If this y-intercept is 6 over a, so it's going to be 6 over 28 over 9, which is 6 divided by a fraction is the same thing. So dividing by a fraction is the same thing as multiplying by its reciprocal, so it's going to be the same thing as 6 times 9 over 28. And this is going to be equal to 6 times 9 is 54 over 28, which is clearly different than 3 over 14. So if a is 28 over 9, same slope, different y-intercepts, and you're dealing with parallel lines. They will not intersect, and you're going to have no solutions.
Okay, that will be all for our lesson for today. On our next video, I have an activity, so please study our lesson about linear equation, because I will give you an activity on Thursday. Okay, thank you.